homework I've shared with you today is regarding the numerical questions of Unit 1. And I'm going to discuss with you some of the most important parts of these questions. I will discuss some questions with you, and you will have to do it yourself, do the rest of the questions yourself, right? So, starting with the question number 1 and part A. Question number 1 says write the number in prefix to power of 10. We have already discussed about the prefix to the power of tens. For the first part, we are given that mechanical nano oscillators can detect a mass change as small as 10 raised to the power minus 21 kg. So the first thing is mass m equals to 10 raised to the power minus 21 kg, and we have to write it down in the form of prefix to the power of 10. So in order to convert it, we first have to resolve this kilo over here. Okay, we have to make it a really simplified form. So mass m would be equal to 10 raised to power minus 21. Remember that we have to convert this kilo into tens power. So multiplied by kilo equals to 10 raised to the power 3 and the gram, of course. So 10 raised to the power minus 21 plus 3, as whenever tens power get multiplied, their powers will get added up or summed up, right? So minus 21 plus 3, we would get 10 raised to the power minus 18 gram. And as 10 raised to the power minus 18 is equal to atto. Atto is a prefix that we are going to use over here. So mass will be equal to 1 atto gram. Of course, here we have 1 multiplied by 10 raised to the power minus 18. So whenever we have some 10 raised to the power any value, it means that 1 is automatically being multiplied over here, right? So we have mass equals to 1 attogram. That is your required answer. The part B and part C of this question are just similar to the part A, so you have to do it yourselves. Coming towards question number 2, part A. Here you are giving that, of course, you have to mention the heading of given data. Right, so given data is that 1 angstrom equals to 10 raised to the power minus 10 meters. The question says that the nearest neutron star, the question says that an angstrom symbol A naught is a unit of length. Alright, so this is what we are given in just the question. So an angstrom is a unit of length commonly used in atomic physics, defined as 10 raised to the power 10 meters, which is of the order of a diameter of an atom. So we basically use this kind of unit in whenever we are going to discuss the atomic physics. The first part says that how many nanometers are there in 1 angstrom. It means we have to convert 1 angstroms into nanometer. So we know that in nanometer we have 10 to the power minus 9. So how are we going to convert this 10 to the power minus 10 to 10 to the power 9? We have to 1 angstrom. Can we write it as 10 raised to the power minus 1 minus 9? Of course we can write it like that, so that we have minus 9 at one place and minus 1 at the other, and meter along with it, of course, right? So we just write it as 10 raised to the power minus 1 multiplied by 10 raised to the power minus 9. So you can see that we have to use the same steps but in opposite way to the question number 1. And here comes the meter. 10 raised to the power minus 1. We can write 10 raised to the power minus 9 as nanometer, right? 10 raised to the power minus 9 equals to nano and meter, of course. So we know that whenever 10 has a negative power, it means that it can be written as positive power in the denominator. So it becomes 10 to the power 1 nanometer, where n is the symbol of nano, right? So 1 divided by 10 would definitely give us 0.1 nanometer, right? So this is your required answer. Okay, and you have to do the rest of the parts, part B and part C, by yourself. If you face any problem solving these questions, then do let me know. Question number 3, part A. So in question number 3, we are given that the speed of light is c equals to 299,792,458 meters per second, right? So the part A is that we have to convert this value into scientific notation. So we have to write it in the form of scientific notation, right? So this was the given data. And we have to find out the standard form. Right? So the solution would become we know that you have to write out the formula. N equals to m multiplied by 10 raised to the power n. This is the formula for writing a number in standard form, right? Where m is the mantissa, 10 is the base, and n is the power, right? Therefore, we can write the speed of light in terms of in standard form as c equals to 299,792,458 meters per second, which is already given. So whenever we have to write down a number in standard form, we have to bring this decimal point right after the first non-zero digit, right? So first non-digit zero digit is 2. So we have to take this decimal point and make some jumps. 1, 2, 3, 4, 5, 6, 7, 8. So we have jumped 8 times in the to the left. So it would become 2.99792,458 multiplied by 10 raised to the power 8. As we go to the left, so we have to write the positive power. It will become meters per second, right? So this becomes your answer in standard form. This is your answer of the speed of light in standard form, right? Now, according to the question, according to the part B of the question, we have to write this number in the form you can say in the form of scientific figure. We have to reduce this number up to 5 significant figure. Remember that now you have to do it step by step. I have told you a method where you can just directly find out the significant figures involved, but here you have to use a step by step method. All right, so part B, section 1, c equals to 2.99792,458 into 10 raised to the power 8 meters per second, which is the exact result of option the section A of question number 3. So we have to use this value, and then we have to convert this value up to 5 significant figures. So C would be, now we have to follow a step-by-step method. We first have to eliminate this 8. So 2.99792. Remember that now we have to keep this value up to this number, this second last number. We have to eliminate 8. So 8 is greater than 5. Therefore, we have to increase 5 by 1. So it becomes 6 multiplied by 10 raised to the power 8 meters per second. C equals to, again we have to reduce it, 2.99792. Remember that now we have to keep it up to this number 4, the second last digit, right? So we have to eliminate 6, as 6 is greater than 5, so we have to add 1 into 4. So 4 would become 5, and we have to eliminate 6 into 10 raised to the power 8 meters per second. Remember that according to the question, we have to round this off up to 5 significant figures. C equals to 2.99792. Now remember that as 5, in the case of 5, we have to see the second last digit. If the second last digit is even, then we have to add 1 to the second last digit. So as 2 is an even number, so we have to increase its value by 1. So 2 would actually become 3 into 10 to the power 8 meters per second, right? So do we have 5 significant figures yet? 1, 2, 3, 4, 5, 6. No, we have to go one step further. 2.997. So as 3 is really smaller than 5, so we don't have to do anything. We would just drop 3, and 9 will be our answer, and to the power 8 meters per second. This is your required answer. And for the second part of section B, you will have to reduce again this number up to 3 significant figures, just up to this number, right? So you have to do this on your own. The other rest of the questions are pretty simple, so I hope you won't find any difficulty solving them. But still, if you face any difficulty, do let me know and we'll figure it out. Thank you so much, everyone.